At 2:17 in the morning, witnesses in the lifeboats heard a sound like cannon fire. It was the keel of the RMS Titanic, 46,000 tons of ship breaking in two. 3 engineering decisions had brought her here, each one defensible on its own, together catastrophic. This is how the safest ship of her era was lost. The Titanic was not a gamble, she was a masterpiece. 882 feet long, 16 watertight compartments, designed so she could float with 4 of them completely flooded. The engineers at Harland and Wolff weren't cutting corners, they were building the future. She could survive almost anything. Almost. April 14th, 1912, 11:40 p.m. The lookouts spotted the iceberg with 37 seconds to spare. It wasn't enough. Here's the part that surprises most people. The total damage was only 12 square feet. 6 narrow buckled seams. No dramatic gash, no Hollywood tear in the hull. Just 12 square feet, with 400 tons of water flooding through every minute. The first failure started in the bow, in the rivets. Over 3 million of them held this ship together. In the main body, high-quality steel, strong and well-made. But in the curved sections of the bow and stern, where machines couldn't reach, workers drove wrought iron rivets by hand. And that iron was high in slag, mineral impurities left over from smelting. At room temperature, fine. At -2 degrees Celsius, the temperature of the North Atlantic that night, brittle. When the iceberg ran along the hull, the rivets didn't hold. They popped. 6 seam failures in the first 37 seconds. That's failure 1. Now the second failure. And this one is harder to see. The watertight bulkheads between each compartment extended only to E-deck, about 10 feet above the waterline, open at the top. As the bow filled and dipped, the waterline rose. When it reached that 10-foot mark, water didn't stop. It spilled over the first bulkhead into the next compartment, then over that one, then the next. The system designed to contain the flooding was accelerating it. The third failure is in the steel itself. When researchers at NIST analyzed hull plates recovered from the wreck, they found an unusually high ductile to brittle transition temperature. In warm conditions, this steel bends. It absorbs impact. At -2 degrees Celsius, it shatters. The hull didn't flex around the rivets, it fractured, giving the flooding a head start the compartments were never designed to absorb. By 2 a.m., the bow was gone. The stern was rising. At around 25 degrees, the keel reached its limit. The forces pulling the two halves apart were greater than the steel could bear. At 2:17 a.m., the ship broke. The bow section plunged toward the ocean floor at nearly 30 miles per hour, 12,000 feet down. It's been sitting there since April 15th, 1912. What a century of engineering analysis has shown us. No single failure sank the Titanic. Not the rivets, not the compartments, not the steel. It was the 3 together, each making the others worse. Engineers call this compound failure. It's the hardest kind to see coming because every piece of it looked acceptable in isolation. The Titanic wasn't a story of carelessness. It was a story of how quickly assumptions compound and what happens when they do.